Good morning, children. How are you all? I hope you all fine. I am very happy to meet you through this digital lesson. So, children, take your textbook, classwork, and pen and sit for the class. Today, we're going to see about types of motion. Are you eagerly waiting for it? Yes. So, shall we go into a class? Okay, children, let's go into class. So, today's topic is types of motion. When we talk about motion or rest, it is with reference to some point. It's known as origin. So now, with respect to change in position, we have two quantities which can be used to describe that change in position. They are distance and displacement. Children, we have already learned about distance and displacement. Okay, children, so this is a recall of what is distance and displacement. So, what is distance? Do you remember, children? Yes, when we move one place to other, the measure of total length we covered, we call it as a distance. So, the total length of a path taken by an object to reach one place from the other is called distance. I am repeating again, the total length of a path taken by an object to reach one place from the other is called distance. So, next we are going to see about displacement. So, what is displacement, children? Do you remember? Displacement is a distance with direction is displacement, or else is defined as a change in position of an object. So, displacement is the shortest distance from initial position to final position of an object. That we call it as a displacement. Both distance and displacement possess same unit. The SI unit is meter. Now, let us see some example in distance and displacement. Look at this picture. This picture shows the motion of a person between two places, A and B. He travels 10 km in first path. In the second path, he travels 7 km. So, what is the direction between A and B? Can you guess? The distance between A and B first path is 10 km. And in second path, the distance is 7 km. So, which is the shortest distance? The shortest distance between two places is 5 km. Because the person travels in a straight line. So, the displacement is 5 km. Now, let us see another example. Look at this picture. The path of an object traveling from A to B. The total distance travelled by an object is 120 meter. The displacement of the object is 40 meter. Why it is 40 meter, children? Can you guess? Because the shortest distance from initial position to final position is 40 meter. It travels through southeast direction. Okay, children, I hope you understand what is distance and displacement. This is a small recall about distance and displacement. Look at this tabular column. Distance is a complete length of a path between any 2 points is called distance. Displacement is a direct length between any 2 points. Distance is a scalar quantity. That means it shows only magnitude. Displacement is a vector quantity. It shows both magnitude and direction. Have only positive values. Displacement can be positive, negative, and even zero. The unit of both distance and displacement is meter. Now say Ben wants to move this table from point A to point B. What will he do? Yes, he will push it in the direction of point B. You see, as he pushes the table, it starts moving. Anything around us that moves, we say that is in motion. So this table is in motion. And since Ben is also moving along with the table, he is also in the motion. In our day-to-day life, we see various things moving around us. Simple example that I can give are vehicles moving on the road, people walking on the street, birds flying in the sky, and so on. Do you know that Earth and the other planets also undergo motion? Yes, they are revolving around the sun. So children, what is motion? Motion is a change in position of an object with respect to its surrounding in given intervals of time. So, we can define the motion as the change of position of an object with respect to its time. For an example, a book falling off from a table, water flowing from tap, and rattling windows, these are all exhibit motion. Even air exhibit motion. The motion can either be swift or slow, but motion exists. Motion is mainly described in following terms. They are distance, displacement, speed, and time. Next, we're going to see about types of motion. We might have noticed that different objects move differently. Some objects move in a curved path, some in a straight path, and a few others in different ways. According to the nature of movement, motion is classified into 5 types. They are linear motion, rotatory motion, oscillatory motion, circular motion, and periodic motion. Linear motion. So what is linear motion? Linear motion means the particle moves from one point to another in either a straight line or a curved path. This linear motion was classified into 2 types. One is rectilinear motion and curvilinear motion. Rectilinear motion means the path of a motion in a straight line. Curvilinear motion means the path of a motion in curved. Okay, so rectilinear motion means the path of a motion is a straight line. Curvilinear motion means the path of a motion is now curved. Example for linear motion is motion of a train, football, motion of a car on the road, etc. Next is rotatory motion. Rotatory motion is the motion that occurs when a body rotates on its own axis. When a body rotates on its own axis. Few examples of rotatory motion is the motion of the earth about its own axis around the sun is an example for rotatory motion. While driving a car, the motion of wheels and the steering wheel about its own axis, it's an example for rotatory motion. Next, we're going to see about oscillatory motion. Oscillatory motion is the motion of a body about its mean position. Oscillatory motion, the motion of a body about its mean position. For an example, you all like to play swing? Yes, we all like to play a swing, no? Yes, when a child on a swing is pushed, the swing moves to and fro about its mean position. This is an example for oscillatory motion. If you see in a clock, okay, the pendulum of a clock exhibits oscillatory motion as it moves to and fro about its mean position. Next, we're going to see about circular motion. Circular motion is described as a movement of an object while rotating along the circular path. Movement of an object while rotating along the circular path. This circular motion has uniform circular motion and non-uniform circular motion. During uniform circular motion, the angular rate of rotation and speed will be constant, while in non-uniform circular motion, the rate of rotation will keep changing. For an example, artificial satellite orbiting the Earth, ceiling fans of blade rotating around the hub. These are the examples for the circular motion. Next, we are going to see about periodic motion. A motion that repeats itself after equal intervals of time. A motion that repeats itself after equal intervals of time is known as periodic motion. For an example, rocking chair, bouncing ball, a vibrating tuning fork. These are the examples for periodic motion. So children, we have seen about 5 types of motion: linear motion, rotatory motion, oscillatory motion, circular motion and periodic motion. Now let us see some examples of motion. Our daily activities like walking, running and closing the door involves motion. There is a change of position of the object involved in these activities. Next, the flow of air in and out of our lungs is also example of motion. The automobiles that carry passengers from the place of pickup to the destination possess motion. In this case, the position of a passenger is changed from one place to another. So these are some examples of motion. Okay children, I hope you enjoyed the class. Now take your classwork and write what are the different types of motion and explain each type of motion with the example. So children, until that, bye and take care. Often wash your hands. Don't forget to pray for our nation. Bye children.